Well, my daughter ran out of smiles and the camera person had to go take care of my daughter. So here we are on the whiteboard for part 3 of our class today. And in part 3 we're going to talk about compounded trig and inverse trig functions. And so you can kind of nest these things together, but it doesn't always make sense to be able to do that. So you want to make sure that the inverse trig functions and the trig functions that you're sort of nesting within each other actually makes sense as a mathematical expression. So I want to start by looking at this first example, and in this example we are asked to find the exact value of the expression, and the expression is cosine of arctangent of -1/4. So there's a lot going on there, but I want to start with the inside and kind of work our way out just to kind of analyze what's going on here. Now this -1/4, we are looking at arctangent of -1/4. The input into an arctan function or an inverse tangent function, the input is a ratio of sides. In this case, the sides are opposite over adjacent, or y over x. And then when we look at arctan of -1/4, the output, in other words, what this value is equal to, the output is an angle. And maybe we'll call that angle theta. Which means that once we have that angle, whatever that angle theta is, then that theta we can plug into the cosine function. So we have cosine of whatever that angle is, and the output will be a ratio of sides. In particular, the ratio of sides that we'll be looking at will be adjacent over hypotenuse, or x over r. So in this particular case, our collection of functions do make sense. The very inside part is an input that's a ratio of sides. That's allowed for an inverse trig function. The output of an inverse trig function is an angle, and so inside of the cosine parentheses is going to be an angle, so that's good. So we'll have cosine of an angle, and that output will give us a ratio of sides. Okay, so now we want to actually try and evaluate this thing. Okay, so let's start with evaluating arctangent of -1/4. And our output will be an angle, and our input, the -1/4, is a ratio of sides. Now when I think about the arctangent or inverse tangent function, the inverse tangent function range is -π/2 up to π/2, but not including those two endpoints. So we're looking for an angle somewhere between -π/2 and +π/2. So thinking about that, that means that we are looking for an angle somewhere between an angle of -π/2 and +π/2. So somewhere on that right-hand side. We do not want to consider angles on the left-hand side. Okay, now in this case, our ratio of -1/4 is negative, and of quadrants 1 and 4, tangent is negative in quadrant 4. So I know that my angle is going to be somewhere in quadrant 4. So I'm going to go ahead and draw that, and I have so many scribbles on that particular picture that I'm going to draw a new one below it. And here is my angle, and I'm going to label this angle as theta. And because we are looking for an inverse trig function, and we're looking for an angle somewhere between a negative angle up to 0, and from 0 up to π/2, this will be a negative angle, so we have a clockwise angle, and it will be negative. Okay, So here's our picture. Now our ratio is -1/4, and that's being inputted into the inverse tangent. So -1/4 is a ratio of opposite over adjacent, or y/x. So that means that our y value will be -1, and our x value will be 4. And I know that the negative goes with the y because we're in quadrant 4. Okay, now I look at this triangle and I ask myself, do I recognize these sides as sides of any of the special triangles? And I stare at it for a little bit, and the answer is no. But that's okay. We're still going to evaluate this without using a calculator, and in fact it turns out we don't actually need to know what that angle theta is. All we need to know is we need to know the sides of that triangle. Okay, so we've drawn the triangle, we have the x value and the y value, and we've drawn a picture of theta. So now we are ready to take that angle of theta and follow it up and evaluate cosine of theta. Okay, so cosine of theta is a measurement of adjacent over hypotenuse, or x over r, and what I want to do is I want to focus on this triangle that we have down here, and I can see on that triangle that I have an x value. So our x over r, our x value is 4, and the r value, well, I still need to actually calculate that r value. I don't know what it is yet, but I can figure it out because I know the Pythagorean theorem. So to get r, I know that x squared plus y squared equals r squared. And so our x is 4, so we have 4 squared plus y squared, so -1 squared equals r squared. So we have 16 plus +1 is r squared, so we have a value of 17 equals r squared, so r is the square root of 17. Cool, so now I can fill that in down here. R is square root of 17. And our x over r value is 4 over root 17. And I might want to rationalize that, so I'll multiply the top and the bottom by square root of 17. And I end up with 4 times the square root of 17 over 17. Okay, it turns out that is our final answer. That is the answer that we're looking for in this particular problem. Now let's go back to the part where we analyzed at the very beginning, where we said, okay, what is it that we're figuring out? We said we're starting with an input that is a ratio. Let's make this a little bit thicker. We're looking at an input that's a ratio, and we plug that into our arctangent function, and that gives us an angle. Now, we didn't figure out what that angle actually is equal to, but we were able to draw a picture of the angle, and from that we could take our theta value, plug that into our cosine function, and cosine of that angle is going to be a ratio of sides. Again, I don't know what theta is, but I know what the sides of my triangle are. I know what the x is, I know what the y is, and I can figure out what the r value is. So cosine of whatever that angle is our x side over our r side, and that will end up being 4 times root 17 over 17. Alright, let's try another example of one of these compound expressions. And in this example, we are going to find the exact value of secant of arcsine, or secant of inverse sine, of -1/5. Alright, now looking inside the parentheses, inverse sine of a ratio of sides is going to give me an angle. So, like we saw in the last example, I may not be able to figure out what that angle is exactly, but I can draw a picture of it. So we're going to start by looking at inverse sine of -1/5, and that is going to be equal to some angle. Now when I think about the inverse sine function, the range is negative pi over 2 up to pi over 2. So I'm looking for an angle of theta somewhere between negative pi over 2 and positive pi over 2. So the angle that I'm going to draw is either going to be in the first quadrant or the fourth quadrant. And our ratio is negative, so that means that my angle is going to be in quadrant 4, because in quadrant 1 sine is positive, but in quadrant 4 sine is negative. So that's where I want to go. So I'm going to draw my reference triangle in here. Here is my angle of theta, and my ratio is negative 1 over 5, and since this is inverse sine, that ratio is opposite over hypotenuse, or y over r. So our y value is negative 1, and our hypotenuse is 5. Alright, now we saw in the last problem that we will probably need that third side of the triangle, so I'm going to go ahead and figure out what that x value is equal to by using the Pythagorean theorem. So the Pythagorean theorem says x squared plus y squared equals r squared. In this case we're looking for x, so we have x squared plus y, which is negative 1 squared, equals r squared, so that's 5 squared. So we've got x squared plus 1 equals 25. So x squared is 24, and that means x is equal to square root of 24. Now, if you're super excited about square roots and things like that, then you might know that 24 is 4 times 6. So you can bring that 4 out and write this as 2 times the square root of 6. It doesn't really matter. Either way will give you an x value, and both are totally fine. I'm going to go with square root of 24, but again, you can choose either one. Okay, so we have the three sides of our triangle and our corresponding angle of theta. Again, I do not recognize these sides as a special triangle or a special angle, so I'm just going to call this angle theta. And now our job is to take a look at secant of that angle of theta. So now we have secant of the angle that we've drawn. And the thing I know about secant is the reciprocal of cosine. So if cosine is adjacent over hypotenuse, then secant is hypotenuse over adjacent, or r over x. And so for us, our r value is 5, and our x value is square root of 24. I do want to rationalize, so I'll multiply the top and the bottom by root 24. And I end up with a final answer of 5 times the square root of 24 over 24. And this is a perfectly fine final answer. If you did choose on this problem to use the 2 times the square root of 6, then an alternative to this, and I'll star it and put it down here at the bottom, as an alternative, you would have 5 times, instead of square root of 24, you would have 2 times the square root of 6 divided by 24. And then you could simplify some more by factoring out a 2 on the top and the bottom, and that would give you 5 root 6 over 12, which also is a fine final answer. Okay, so back to the beginning of this example, we wanted to find the exact value of secant of inverse sine of negative 1/5. So we started with that ratio of sides, the negative 1/5. We identified where the triangle lives based on whether that ratio was positive or negative, and based on the range for inverse sine. Once we drew the triangle and had our theta there, then we could calculate secant of that angle theta. And our final answer is a ratio of sides. Okay, so here's my thought on these guys. It's not that often that you're going to see too many of these compound expressions when you're walking down the street. But on the other hand, being able to evaluate these expressions means that you know what you're doing when it comes to dealing with all of these trig functions, both regular trig functions and the inverse trig functions. So I encourage you to think through these, work on the practice problems, and then stop in to the Zoom office hours if you have any questions or want to go over any of these. All right, thanks for listening. Bye.